In this video, we'll be talking about rounding whole numbers and about rounding decimals. And we need to know how to round whole numbers and decimals because we use this skill when we estimate and when we do computations with metric units. So we'll start out with rounding whole numbers, and the same rules apply to both, but we'll start working with our whole numbers. We can round whole numbers by using the rounding rules, and there's 3 steps in order to round. First, we're going to underline the digit that we are rounding to. In our second one, we're going to compare that digit to its digit to the right, its neighbor to the right, and this is where we have our rounding rules. If the digit to the right, if that number is less than 5, so if it's less than 5, then we round down. And then if it is greater than or equal to, so if that number is greater than or equal to 5, then we will round up. Now, it doesn't mean that when we round down that the number that we are rounding to changes, but that everything to the right of it becomes zeros. So again, if the digit to the right is less than 5, the underlined digit stays the same. Everything else to the right of it goes down to 0, and if the digit to the right is 5 or greater, the digit that we're rounding to increases by 1. So, and then everything to the right of the digit we are rounding to, we rewrite as zeros. So let's practice that. So we are going to round 43,658 to the nearest hundred. So again, we're going to underline the digit that we are rounding to, which is our 6, because the 6 is in our hundred place. So this is, remember, we have to round to a certain place value, right? Here is our 100. So our 6 is what we're rounding to. We look to the digit to the right. So the 5, that is the digit to the right. And since 5 is 5 or greater, we are going to round up. So that 6 now becomes a 7, and everything else to the right, that 5 and the 8, they become zeros. Let's try it again. So we're going to round 9,309,587 to the nearest million. So again, we're going to look at what digit is in our million place. Well, it's at 9. And we're going to look to the digit to the right. And the digit to the right is a 3. So since 3 is less than 5, we are rounding down. Now, it doesn't mean that it's going to become 8 million, but everything to the right of it becomes zeros. So we round down to just 9 million. So here, let's try to do some on our own. So round each number to the place value of the bold-faced digit. Alright, so we have our 8. The 8 is our bold digit. So we're going to underline. What is it that we're rounding to? It was the 8. And we're going to look to the digit to the right. And so since 7 compared to 5, well, 7 is greater than 5. So we are going to round up. So to now rewrite this as we have rounded, it's going to become 39,000. Because the 8 is what we're rounding to, the thousand place. The 7 to the right of it is greater than 5, so that means we round up. So it should be 39,000. Alright, and our bold digit here is our 4, is our 3. So digit here is 3. So we are going to round, we're looking at our 3, and we look to the digit to the right, and that's our 2. Since 2 is compared to 5, it's less than 5. That means we are going to round down. So we write this as 719,430. Let's try another one. So we're going to round 2,409,485 to the place named. So we are going to round to the 100,000th place. So what number is in our 100,000 place? Well, we have our million, and then 100,000 is our 4. So I look at our 4, and I'm going to look to the digit to the right. And since the digit to the right is a 0, 0 is less than 5, so we are going to round down. So we rewrite this as 2 million even. 2 million, because the 0 says we round down, so everything else becomes zeros. 2 million. And our last one on this one, round 2,409,485, and we're going to round to the hundreds place. So we find what number is our hundreds place, and that's our 4. So we look to the digit to the right, that's a 8. So we compare 8 to 5, well 8 is greater than 5. So that means that we will round up. So we rewrite this as 2,409,000, and since we have to round up, that becomes 500. Since the 8 is greater than 5, it tells the 4 to go up, so 2,409,500. Alright, now we're going to look at rounding decimals, and again the same rule applies. We are going to underline the digit that we're supposed to round to. We compare the digit to the right. If that digit to the right is less than 5, so the digit to the right, if it is less than 5, then we round down. And if it is greater than or equal to 5, because it could be 5, and if it's 5, then that means we have to round up. And then we rewrite all the digits to the right of the digit we're rounding to as zeros. An equivalent decimal can be written by just dropping off all those extra zeros, because the value of it stays the same. The name may change, but the value stays the same. So let's take a look at this. First example here, we have round 5 and 643 thousandths to the nearest hundredth. So our 4 is in our hundredth place. So we look to the digit to the right, and it's a 3. Since 3 is less than 5, we are going to round down. So changing that 3 to a 0, we have 5 and 640 thousandths if we turn that 3 to a 0. But since it's a trailing 0, it's to the right of the decimal point, the value of the number doesn't change. So we could write it as 5 and 640 thousandths, or we could write it as 5 and 64 hundredths. The value of it stays the same. Let's look at the second example here. Round 8,287 ten thousandths to the nearest thousandth. Well, what digit is in our thousandth place? Well, it's the second 8 right here. And since the 8, we look to the digit to the right, and the 7 is greater than 5, so we have to round up. So we rewrite this as 0 and 8,290 ten thousandths, or we could just say it's 829 thousandths. The value is the same. The name changes if we have that 0 there. Either way would be correct. So let's try and practice this ourselves. So we're going to round 4 and 1,872 ten thousandths to the place of the bold-faced digit. And our bold-faced digit is this 1. So if we look at the digit to the right, which is an 8, well, comparing 8 to 5, 8 is greater than 5. So that means we're going to round up. So we rewrite this as 4, and since we have to round up, that 1 becomes a 2, and we could write all the remaining digits as zeros, or we could just write it as 4 and 2 tenths. Excuse me. Second example, round 82 and 64,751 hundred thousandths to the nearest thousandth. So we're going to look at what digit is on our thousandth place. And that would be our 7. So we look to the digit to the right, and it's a 5. Well, 5 is equal to 5. Remember, if we said that the digit, if it was greater than or equal to 5, then that means we have to round up. Since it is 5, that means that we need to round up. So that means that our number changes to 82.648, or we could say it would be 82 and or 0.6480, or yeah, 80. Either one would be correct. Preferably, we would write this way, but that's fine. Round each number to the place of the bolded face digit. So if we look at this number here, 7.325, we look to the digit to the right, and it's a 2. So since 2 is less than 5, that means that we round down. So we'd say that this would be 7 and either 300 thousandths or 7 and 3/10. And here we have our 2 is our bolded face digit. So we would look to the digit to the right, and it's an 8. And so this would be 9.03. Now we have our 0 is what we're rounding to. So we look to the digit to the right. We have an 8. So this would be 108 and 12 hundredths, because the 8 is greater than 5. 8 is greater than 5. So that means we round up. And for this last one here, we have 26, and that 6 is what we are rounding to. So we look to the digit to the right. Even though it's a decimal and the 6 is our whole number, we have to round. The same rule applies. So we would say this would be 26, and I could put all the zeros there, or it's just 26. All those trailing zeros do not change the value of the number. So I would just really want to write it as 26. Alright, so now we are rounding 12 and 8,400 5/10,000ths to the place named. So if we look at our hundredth place, well, that would be our 4. So we look to the digit to the right, and it's a 0. So that means that we are rounding down. So that means that this would be 12.84. Alright, let's try it again. I'll use a different color so that we don't mix it up. And we're going to round to our ones place. And our ones place would be our 2. So if we look to the digit to the right, it's an 8. So that means that we are going to round up. So this would end up to be 13. Let's try again with our tenths. So our tenths place would be our 8. We look to the digit to the right, and it's a 4. So this would be 12.8, because the 4 is less than 5. So that means we have to round down. So we would just leave it as 12.8. And let's do our last one when we round to our thousandths place. And our thousandths is our 0. So we look to the digit to the right, and it's a 5. Remember, if the digit is 5, or if it's equal to or greater than 5, then it rounds up. So this would end up to be 12.841. Because that 0 is 0, the 5 says go up, and we go up by 1. So 12 and 841 thousandths. That's the end of the lesson on rounding decimals and whole numbers.